So welcome to our webinar, our first webinar in the fifth session. Fifth session. So seasons. Basically, we have 5 seasons already, been 5 years. We organizing Friday forecasting talks, and we are aiming for more longer years to organize this type of webinars. So this in this webinar, we have Nicola. She is a lecturer in health data science. So, and then the top would be effective visualization for improving communication with decision makers. And I will give you some overview what we are doing as a center. So we can provide you guys with services, with consultancy, MSc summer project, software development in R, or we can also do a KTP, knowledge transfer partnership, or PhD project. We also have variety of expertise in marketing analytics, demand forecasting, inventory management, statistical learning, etc., etc. So if you want to get in touch with us, just get in touch. You can go to our Twitter or X. We are active on LinkedIn. You can contact us on with email, or also you can go to our website. We also have some educational videos provided by our members. The last video was delivered by Stefan Kolasa. He is expertise in retail forecasting. So please have a look and subscribe, like, and share. Okay, so I think I'll stop my screen and I'll let Nicola to share her screen. Please.
So thank you very much for inviting me to give this talk. So I'm going to talk, as Kendrika said, about sort of more effective visualizations, particularly thinking about how we communicate with decision makers in our projects. So to give you a very brief introduction to myself, I'm a lecturer in health data science based within the Centre for Health Informatics, Computing and Statistics at Lancaster University in the medical school. Although I'm now based in the medical school, my background is in statistics and operational research. So I actually started out looking at sort of forecasting demand for transport systems. And then I worked in data science consultancy for a while before I joined GCAS last year. A lot of what I do at the moment is collaborating with local NHS trusts on different sort of data science and data engineering projects, and some of those are forecasting related and some of them aren't. The other project that I've been working on over the last couple of years is with the Royal Statistical Society, the RSS, and I co-authored their best practices for data visualization guidance, and that is mostly what I'm going to talk about today. I first got into thinking about visualization when I was working on some forecasting projects. So I started thinking about how do we identify forecasts that are no longer as accurate as you'd like them to be, and how do you alert a human being to that? And when you're dealing with, in the data we were looking at, it was something like 70 million forecasts. You have to be very selective about the way you communicate that to analysts and in a way that's useful. So thinking about the project with the Royal Statistical Society, I wanted to start with a little bit of background about how this project actually started and why we actually developed a data visualization guidance in the first place. And so this project sort of started back in around 2021. So the RSS send out surveys to all of their members, and they asked them about their views on Significance magazine. So if you haven't heard of Significance before, it's a sort of less technical publication than a journal, but it sort of publishes sort of statistics or data-related articles. And one of the questions that respondents were asked is what aspects of content and significance could be improved. And a lot of people came back with some comments about the visualizations. So we're looking at sort of better, more consistent charts, I think one person said they'd like to see a sort of significant style, a little bit like The Economist. And we always sort of say we'd also love the budget that The Economist have for visualizations, but we don't quite have that budget. Some of the other comments were that the figures that are in the articles are quite difficult to read. And the one that kind of really struck me was that there was a comment that sometimes the plots look like they were done by an amateur. And I think that really struck me because these articles are written by people who are very experienced, are statisticians, very, very good at working with data. The methods they're using are often quite complicated. And the first impression that someone was getting of that is that it looks amateurish. So it was sort of, let's try to do something to address this, to make sure that people can trust the content they see and that it reflects the quality of the work that's actually been done. So we put together, the RSS put together a team. So I was working with Andreas Karls, who at the time was based at Idorsia Pharmaceuticals, myself, and then Brian was our connection sort of at the RSS. And after thinking about what do we want to achieve with the guide, our primary aim was thinking about how do we help contributors to Significance magazine and other RSS publications to develop visualizations that are appropriate. But we also wanted it to be a more general source of information. So for people who are developing visualizations for other purposes, not just for RSS publications, to help them develop charts that are sort of higher quality and more effective. We were very aware that there is a lot of information already out there about visualization, and we didn't want to just sort of rewrite it and publish that. So it was sort of summarizing and linking to advice that already exists for different types of data and different types of charts. The other aspect of the project was actually showing people how to implement it. So we developed packages in both R and Python to help people override some of the default settings so that, when you spent a long time developing an article, it's a bit of a nightmare when a reviewer comes back and said that they want to remake every single one of the plots in your paper. So what we wanted to do was, okay, let's develop some software where people can add a couple of lines of code and it will update all the visualizations to match the sort of styling that we're recommending. So about a year ago, we published the guide online. So the guide itself is fully available online, and the source code for the guide is also fully available online. So it's all open source, and all of the sort of review processes and comments from people are also public. So it's very much aiming to be a community source of advice about data visualization. So that's the background and how the guide came to be. So for the rest of this talk, what I'm going to talk about is basically why should you visualize data in the first place, some guidelines for making better charts, and we'll look at some examples of good and bad charts. So starting with thinking about the role of visualization. When I think about data visualization, I often refer to it as the sort of bookends of data analytics projects. It's usually one of the first things that you're going to be doing, but it's also quite often one of the last things you're going to be doing. So when you first receive some new data or you first start a project, you want to be using visualization to explore your data and do things like identify issues with the data and think about what modeling approaches you might take. But then when you're sort of finished or almost finished the project, you also want to use visualization to communicate those insights or those results to other people. And that might be through presentations to stakeholders. It might be through journal articles or sort of conference presentations. And visualization is a really effective way of doing that. So I'm mainly going to focus on using visualization for communicating results. And the reason why visualizations work well for communicating insights is that they stand out quite clearly. So I don't know about you, but when I read through papers, I quite often flick through them and I do look at the pictures first. So they grab attention, and if it's if it's a visualization that looks interesting, it might draw me in to read the rest of the paper. It's also a way of improving access to information. I see quite often people sort of write results in the middle of a sentence, and they might put things, like confidence intervals in brackets, and it gets quite hard to read. And people tend to do things like round numbers a little bit more to make them, nicer to read in a sentence. But if you're doing something like a scatter plot, you're plotting the exact data points you have. It's also quite a good way of summarizing content, sort of using diagrams and visualization. If it's something that's complicated, you can sort of sum it up in something that's usually easier to remember. And so when you're thinking about making a visualization for a paper or a presentation, it's important to think about what's the purpose of it? What is it that you're trying to communicate with that chart? Okay, so most presentations will have a time limit. Some journals will have a limit on the number of plots you are allowed to include in a paper. So you have to be quite selective and think about what is the purpose of this particular chart, and does the visualization that you've chosen to do actually support that purpose? And I think it's also important that when you make visualizations, they should be sort of quite quick to understand, quite accurate, and quite intuitive. So I often like to say that if someone looks at your visualization for 5 seconds, they should probably come away with the same message as someone who looked at it for 5 minutes. Okay? Because most people are not going to spend the 5 minutes. They're going to look at your visualization quite quickly and take that message away and then move on. So I wanted to address a couple of sort of visualization types that often have a bad reputation. And one of the obvious ones is pie charts. People have a lot of hate for pie charts. So here's an example of a very simple pie chart. Okay, so just two segments, A and B, and here's another version of a pie chart, again with segments A and B. So if I asked you to think about the visualization on the left, the pie chart on the left, and estimate, let's say, the size of segment B, there's different aspects of that pie chart you might be looking at. Okay, so one of the things you might be looking at is the angle. Okay, you might be looking at the area, you might be looking at the arc length, or you might be looking at the chord length. Okay. And the problem with that is that the aspect of the visualization that people tend to use to estimate the size of segments varies depending on the size of the segment. So for small segments, we typically look at things like angles, but for larger segments, we might be more inclined to look at area. So the way your brain is processing that information is sort of varying depending on what the information is. Okay? So pie charts are not great for accurately displaying information. Right? And that's not to say there's never a use case for pie charts. I did make one recently, but it's about thinking about, does the purpose that you're making this chart for, is it actually supported by a pie chart in this example? The other type of chart that people tend not to like very much is 3D charts. Okay, so I'm going to ask a really simple question. Okay, so you have the plot on the left. Okay, it's a very simple plot. It's a bar chart showing one number. How tall is the bar? So what number is represented by that bar on the left? Okay, feel free to drop a guess in the chat if you like. So when you're looking at this chart, you might start looking at the front of the bar and going along, and it's somewhere a little bit above 10. But if you sort of follow this line for 10 round to the back, the line for the bar is also below 10. So in this chart, you've managed to display a number that is both bigger than 10 and less than 10 at the same time. Right? So that's kind of where, when we're thinking about the purpose of a chart, if the purpose is to accurately show how big a number is, this isn't doing it very well. And you can see there's sort of other problems, sort of similar problems with the one on the right. Okay, so the 4 tallest bars here all have the same value, but because they're presented in this sort of 3D fashion, it looks like there's some sort of linear decreasing trend here. Okay, so it's sort of showing you a pattern that doesn't actually exist. So we've seen a couple of examples of not so great visualization types. So what I'm going to talk about next is, well, how do we design ones that are better? Break it down into different elements of charts. Okay, so there's so many different things that you can think about when you're building those visualizations. Okay, it might be the layout, the aspect ratio, you know, what type of plot are you making? Are there lines? Are there points? Are you using colors? What variables are on each axis? Are you using symbols to represent data? Is there a legend? Is it sort of landscape or portrait? Are you adding any other elements like annotations? And these are all choices that you want to be making actively. So I'm going to start by going through a couple of different examples. Okay, so here's a chart looking at let's say you have 5 different methods, A, B, C, D, and E, and you want to compare the performance of these different methods. And so one of the comparisons you're making is looking at the distribution of prediction error. Okay, and quite often people will do things like make a density plot, for example. And you can, as you can see here, sort of layer those density plots on top of each other to get a comparison of how the distributions are different. Even with just 5 groups like this, it starts to get quite complicated looking, and the sort of lines start to sort of join up, and it's hard to see which one goes with which group. So what you might do instead is split them up and plot them separately using sort of facets or small multiples. But then I want to think about what is it that I'm interested in comparing. Usually with this, I'm interested in comparing sort of the mean or the median of each group, and also the variability of each group. Looking at this chart, it's quite hard to compare, for example, C and D. Okay, they look vaguely similar. If I change the orientation of the facets so they're now stacked in a column, it becomes much easier to compare those distributions to each other, because the things I'm comparing are now sort of stacked in a line rather than being quite far apart. And I think this is a nice example of it's a very tiny change. Okay, I've changed one line of code, just flipping around whether it's in a row or a column, but it makes a big difference in how easy it is to actually understand and use visualization. Another example that I like using is when you're plotting some sort of categorical data. People quite often put their categories down here on the x-axis, and as you can see, when you have these big sort of long labels, they all blur into each other. And I think what quite a lot of people do is they sort of end up rotating these labels quite a bit, and you can always tell when someone gets to that part in the paper because suddenly their sort of neck goes to one side as they try to actually read the labels. It's much easier if you just put the labels on the y-axis so that they are very readable. Right? Again, it feels like a tiny change, which is perhaps somewhat obvious, but it just makes your sort of reader's life a tiny little bit easier. I have just shown you an example with box plots, and I'm now going to tell you that the box plots are also not great. So box plots hide a lot of information. Okay, box plots are essentially just showing you summary statistics, and so you lose a lot of information when you show your data in a box plot. Okay, so the one on the left shows box plots for 5 different data sets, and the box plots look pretty much identical. But if you actually look at the distribution of the data, these are 5 very different distributions. Okay, so box plots can be useful, but they do also hide quite a lot of information, so it's important not to rely solely on box plots. So another sort of classic question is, should the axes of your chart start at 0? Okay, so here's a sort of classic example. You're comparing your product to your competitor's product, okay? And these are two charts that show the same data. The only difference is the one on the right, the y-axis starts at 0, and on the one on the left, the y-axis starts much higher up at sort of 208. So this is a key example of that idea that someone should get the same conclusion after 5 seconds as 5 minutes. Okay? If you spend a little bit longer looking at the chart on the left, you will eventually notice that, okay, it actually starts at 208, and that's not very different. But your first conclusion when you look at this chart is, oh, our product looks 5 times better. Actually, it's only a tiny little bit better. Having said that, the y-axes don't always have to start at 0. Okay, so particularly when you're looking at something where 0 is not a reasonable value. Okay, so I've used the example of population here, but other things like temperature is also a good example. If you're looking at something that the sort of baseline is quite far from 0, and you include 0, you sort of end up stretching your chart and everything just gets squashed into a straight line at the top. So it's thinking about what is the purpose of your chart. What is it you're trying to show? Another thing to think about when you're thinking about axes, okay, so thinking about categorical axes, is what order you put things in. Okay, so this is an example looking at the GDP of sort of 5 different countries. And if I ask you to tell me sort of, which one's biggest, which one's smallest, or to rank them, it's quite hard just by looking at it. Sort of the UK, Germany, and Finland, those values are all quite similar, and it's quite hard to figure out where those actually sit. But if you order them by magnitude, it becomes very easy for a reader to just look up, okay, this one's at the top, and then here's the order. Here's another example of a chart, and I'm going to give you a couple of seconds to look at this one. And if anyone wants to point out anything they think might be wrong with this chart, feel free to drop it in the chat. Yeah, exactly. Okay, so the order of the dates on the x-axis is the sort of main issue. Okay, so at least in my lifetime, only ever goes forwards. But in this chart here, time is sort of going backwards and forwards. Okay, we're going sort of April to May and then back again. So your first conclusion when you look at this is you start to see, okay, there's a bunch of dates on the x-axis, and it looks like those bars were showing the number of COVID cases were going down, so COVID cases must be decreasing. The other point is that the number of bars, sort of the bars within each date, have also been ordered solely on magnitude, so they're changing order all the time. It's much clearer if you have a consistent order of bars. Okay? So it's thinking about ordering categories in a way that's appropriate. Okay? So the default settings in a lot of software will either be to order things alphabetically or in the order that the data appears. That there are arguments sometimes for either of those things being appropriate, but there might be times when you want to order by magnitude unless there's a natural ordering of the data. Okay, so these are examples looking at day of the week. Okay, default ordering doesn't really make any sense going alphabetically. Ordering by magnitude is also probably not very intuitive, but ordering them in the days of the week in which the days of the week actually occur is much more useful, and it allows you to actually pick out the patterns that are in the data. For the last part of this section, I'm going to talk a little bit about plotting lines in your data. So when you use lines to join two data points together, you're usually suggesting some sort of order between the things that you're joining up. So if you have categories, and there isn't a natural ordering through those categories like days of the week, it doesn't really make sense to draw lines between them because there is no order of those categories. Okay? Particularly because lines also suggest continuity. It suggests there's something in between those two data points. It's quite common when you're working with things like time series data. If you have multiple time series, you want to see what's going on across those different time series. But if you just sort of plot all of the lines on one plot, it quickly ends up looking sort of what we call sort of spaghetti plots. It's really hard to actually follow a line and see which line goes where. Particularly when you're using different colors for different lines. The colors sort of blend into each other when you have so many groups. So some alternatives this might be showing a smaller number of lines. Okay, so in this one you have well over 20 different lines. Do you actually care about the values of every single one of them? Or are there a few you care about and maybe you want to compare those to the average? Another option is using sort of small multiples or facets, okay, and sort of splitting those up. So you might, in this example, split them into different regions and maybe show sort of 4 or 5 different lines on each small multiple chart. The other option is to use color to highlight a particular line. So you're still sort of plotting all of the lines, so you can see a general pattern of what's going on across everywhere, but you're highlighting a particular individual line and saying sort of this is how it compares to all of the others. Continuing on with that thought of using color for highlighting, let's think a little bit more about when and why do you use colors in your data visualizations. So the key thing is that colors should, again, serve some sort of purpose. So, for example, showing different groups of data. Okay, if we go back to that example of 5 different methods, A through to E, there might be 5 different colors. But you can also use colors to highlight or emphasize a particular part of your data, basically using color to direct your reader to what it is that you want them to look at. Color isn't always the most effective way. For example, for communicating differences between variables. So it's quite common if you're making something like a scatter plot to use color to sort of encode a third variable and the value of it. It's a little bit more difficult for a reader to accurately see the difference between two variables if you're sort of asking them, what's the difference between a red point and a yellow point? When you are using colors, it's useful to think about your choices of color and to make them as intuitive as you can and sort of match the type of colors you're using to the type of data that you're using those colors to represent. So if you're showing a sort of continuous variable, it's useful to use a sequential color palette, so going from dark to light or vice versa. If you're showing data that is, for example, how far above or below 0 it is, or how far above or below average each data point is, then a sort of diverging color palette is useful, okay? Sort of going lighter or darker in each direction. And if you're working with sort of categorical data, then using these sort of qualitative or discrete palettes are useful because they make sure you don't imply some sort of ordering to the categories if there is none. So again, post in the chat if you think this is a good choice of color for this chart. So this is the same chart of GDP that we saw earlier, okay, but here the bars are different colors. So one comment about this chart is that the colors are kind of unnecessary. They don't give you any more information than the axis labels do. If they were all purple, you'd have the exact same amount of information that you already have, right? So it's sort of, you're using color for decoration, but you're not actually giving a reader any more information. The other problem with these choices of colors is that they're not actually very accessible. Okay, so there's different types of color blindness, which makes different colors look similar to each other, and if you look at this chart here, the sort of strength of each color is basically the same. So it makes the problem even worse. Okay, they're all sort of equal intensity. As well as thinking about color blindness, it's also useful thinking about what do your images look like when they are printed in black and white. Okay, so I have been caught out with this in the past. Okay, so when you send a paper off for review and your reviewer prints out their paper because they like going through things sort of by hand, and then it's cheaper to print things in black and white, and then your charts that rely on color make absolutely no sense. Okay? So in this example, it doesn't really matter very much because the colors don't add anything, but you can imagine if this was a scatter plot and those 5 colors showed 5 different groups of data, when you print that in black and white, it's going to look just like one big group. It's not going to show any difference. So it's useful to sort of double check how accessible are the colors that you've actually chosen. And when you do use colors, you very often create a legend to show, okay, what color represents what value or what category. And so there's some ways that you can improve the legends. So again, thinking about accessibility and how do you match a color to a data point, it's much easier if you directly label things. Okay, so like the example on the right, put the sort of category name right next to the data. Okay, so people aren't having to try and match a color over here to one over here, and try to keep it in a logical ordering. Okay, you can see the example on the left. The colors in the legend are basically the opposite way around to the actually appear in the data. So you're sort of moving further across the chart to actually check which category is which color. So sort of key points to take away from this is that when you make a visualization or you make a plot of your data, it should have some sort of purpose, and you should know what that purpose is and have chosen a visualization and designed it such that it supports that. So it's thinking about actively designing your visualizations rather than just, throwing it into your software of choice and letting the default settings be used, because the default settings aren't always the best choices. They are simply just someone else's choices. I also want to sort of make the point that every sort of rule or every piece of guidance I've mentioned should probably be broken for some type of visualizations. Okay, they are sort of guidance, not sort of very clear rules that you have to follow every time. There's always going to be exceptions. The last thing I want to sort of mention is that the good charts don't have to be boring. So sometimes when I talk about visualization like this, it feels like I've done a talk which is a lot of don't do this, don't do that, here are all the rules you have to follow, But good charts don't have to be boring. They can be interesting, they can break those rules, but they can still be clear. So I wanted to show you a couple of examples of some different charts that I really like. Okay, so this is a chart looking at the number of different colors of Lego bricks that have been available over time. Okay, so I really like this chart. And the key thing that makes this chart, I think, work well is that the bars are ordered based on colors. Okay, so you can see in here, there's sort of various different shades of sort of white or light gray. If they were arranged by, say, color name, this would just look like a big blurry mess. But they're sort of being ordered such that all of the red ones are together, all of the blue ones are together, and it's easier to see what that pattern is. Another example of a chart that I really like, and I think could be quite useful in the setting of sort of looking at forecasts potentially. Okay, so this is looking at how far above or below some baseline a particular sort of set of scores were. So you can see that it says color coded based on whether the data is above or below this baseline, and they're all ordered as well. Okay, so the sort of best performance is the top left down to the top, the bottom right, which is the poorest performance. Another example here. Okay, so this is looking at this sort of radial chart. Another example of how things like pie chart inspired visualizations are not always bad. And finally, this last one from Dan. Okay, this is a very simple chart. It's showing just 4 data points, but the explanation is very, very clear. Okay, and it writes out the message that you should take away, that fossils are down, renewables are up. Okay, so it shows the data and it gives you that very clear message. Okay, so this might not be the type of chart that sits particularly well in an academic journal article, but it will work very well in a presentation. Okay, if you sort of put this chart up on the screen, big room, it's a very clear message to take away. The last thing I will mention is that, as I said at the start, the data visualization guide is completely open source, and we do want to encourage contributions from the community. So if there's something in the guide that you disagree with, or if there's something that you think is missing, okay, so if there's you want to see some more examples of how do you communicate forecasts or how do you communicate spatial data and you don't see those in the guide, feel free to either tell us about it or write it and we'll add it in. So the guide is built with Quarto, which is an open source publishing system. It's all fully reproducible, so you can combine the sort of text in the guide with the code that builds the plots. The guide has examples in there's some in Excel, but most of the examples are sort of in R or Python or Julia. So the source code for the guide is on GitHub. You can have a look at that. There's also a guide I'd like people to contribute and what we'd like you to contribute. So you can add an issue if you find something you disagree with, or if you find a typo, we're always open to people fixing those for us, or contribute to some of the existing discussions that are going on about the guide. Okay. So these slides are available online. I'll post a link in the chat in a second. The guide itself is also online, as well as the sort of, if you subscribe to Significance magazine, you can also read it in print format as well. But I'll leave you with the link to the guide. So thank you very much.
Thank you, Nicola. It's very interesting because for me, data visualization, well, some people would think that the visualization is very trivial stuff, like it's very easy stuff, but then it's basically very important in the sense that we can convey the message correctly or not, right? We can lie some information using the data. So I think it's quite. I think the important point here is the way that our brain processes different type of information. Sometimes I think you also show the example how different angle could potentially change the way we think about the data and also focus on the reader. But I have a very technical question. This is possibly my personal question. And if you have any question, just please let us please put them on the chat. What about the font, Nicola? Because I'm quite struggling to find a appropriate font size for pictures in any publication, either magazine or article or kind of thing. So whether it should be the same as the font size in the body text, or it should be smaller, or what do you think about it?
So maybe I'm just getting older, but I generally think that font sizes in visualizations are generally too small. So I know when we were looking at implementing things for publication, some of the recommended font sizes were things like size 5. And if you're reading an online version, you can zoom in, that's fine. If you have printed that out on paper or you're reading the print version, that can be really hard to read. So I would, bigger font sizes are better because they are just more legible. So I think if things like subtitle text in a chart, I personally think should be the same size as text in a paper, just to make it as easy to read as the text. Some journals do have very specific, this is what font you should use and this is what size it should be. But I would encourage you to push back against that a little bit, particularly thinking about things like accessibility. You know, the type of font you choose and how big that font is does impact how easy it is to actually read.
Yeah, thank you. So I think there is a comment from Nick here. He is they are the methodologist, and we are really struggling to visualize, assemble, or probabilistic data. So maybe you have a comment on that, probabilistic, how we can.
Yeah, I think this is actually a comment that someone left on the guide quite recently about adding something in about how do you visualize uncertainty. And I think that it's a really challenging problem, because when you don't want people to lose trust in your forecast or your method because you're showing them uncertainty, but you also have to be honest that your method is not certain. So thinking about ways you can visualize uncertainty, I think is really important. It's not something that's in the guide currently, but if you have ideas and you want to contribute, please feel free. I've seen a few different approaches to visualizing uncertainty. I think what I've been kind of doing recently is sort of showing scenarios. So rather than showing sort of one visualization, you show a bunch of different visualizations based on different potential outcomes, and that sometimes works quite well. But yeah, I would love to see some more stuff on visualizing uncertainty.
Yeah, I think I usually watch videos from Met Office. They usually provide quite clear scenarios from this scenario, from the other scenario, because they want to show some uncertainty there. Okay, that's really nice. Is there any burning question, or is there any question from the chat? I don't think so. So maybe let's stop at this point. Thank you very much, Nicola, for the insight. Again, just eye-opening how we see visualization differently. Okay, thank you, and see you in the next Forecasting Friday talk. Bye-bye.
Thank you.